Good morning all. Good morning everyone. Guys, I'm extremely sorry because I couldn't able to take classes continuously because of bit academic works and all. And you know, for foremost, I would like to request you guys, so please wear masks in house also. Okay, so why? Because the situation is not at all good. Even I am also facing lot of symptoms related to COVID-19. Okay, so that's the reason why I request everyone, so please you know, be safe. Okay, don't go out. Okay, so I will try to take all classes from the home itself, because from today I am in quarantine. Don't worry, I'm gonna finish the syllabus within the time. Okay, I'm really sorry for not taking the classes regularly, guys. Okay, I hope you can understand this. Okay, so let's continue the class where we stopped the problem in the previous session. I request all of you, so please open your books. And I am also uploading the same video in the YouTube also. You can also go through the videos and you can continue the classes. Okay, so where you will be updated with the lecture notes and all, right? Guys, we will try to continue the same problem. I think we left a problem at some point. Okay, yeah, so let me add every student. So there are a few students came just now. Okay, yeah, guys, are you able to see my screen now? Guys, anyone, can you respond?
Yes, sir.
Yes.
Yes, sir. We can.
Yeah, yeah.
Yes, sir.
Okay. Okay. Right. See, I think we are solving this problem where we stopped. So here it is very important. So where you have to understand the problem carefully. So I think in the previous session, so we have solved this problem. So here in this problem, it's clearly mentioned. They are asking you to calculate the deflection under the axial load, right? So based on the, so here there are 2 points. So this is an open coiled helical spring. Open coiled helical springs usually subjected to bending and subjected to rotation, isn't it? Okay, and subjected to moment and subjected to torque. So in this request, we have calculated, one second, yeah. So we have calculated T and M. What is T? T is the torque and M is the moment we have calculated from this problem. Okay, based on the load acting on the spring. So which is 300 Newton. And not only that, what they are asking, if you see this problem carefully here, if the axial load of 300 Newton is replaced by an axial torque of 8 Newton into meter. See, based on the 300 kilonewton force, we have calculated deflection delta and the bending stress and the shear stresses, isn't it? So now what they are requesting us, they are asking to replace the load with an axial torque of 8 Newton into meter. So with that, what will be the angle of rotation and what will be the axial deflection when you replace the load with the torque of 8 Newton into meter? Okay, so that is what they are asking us to do it. Okay, now we will continue the problem and we will try to solve problems on other components also. Okay, right. So let me open this. Okay, so just see what parameters we have calculated in the previous problem, in the previous session. So for the same problem, we have calculated torque. How much is the torque? 14672 Newton into mm, isn't it? And next we have calculated even moment also. What is the moment? 3119 Newton into mm. So based on the torque and moment, we have calculated bending stress and the shear stresses, right? Which is acting on the open coiled helical spring, isn't it? So we have calculated the deflection. Deflection we have calculated And what is the deflection which we got in the previous class? Delta 6.86 mm, isn't it? Right? And so this deflection is with the load of 300 kilonewton. So when the spring is subjected to a load of 300 kilonewton, okay. Okay. So for this deflection, sorry, for this load, the deflection is how much? 6.86 mm. So next, in the same way, we have calculated stresses. One is bending stress and the other one is shear stress. So what is the bending stress which we got? What is the bending stress? How much we got the bending stress, Amma? Can anyone?
9.41.
Very good. 9.41 Newton per mm square. Right? And what is the shear stress? 22.1 Newton per mm square. Okay. So these are the parameters which we got in the previous session. Right? Now, what we are going to do is we are going to calculate the consolidated stress. Okay. So nothing but the stress based on bending and shear. Okay. See, individually you can able to see the bending stress is 9.41 Newton per mm square. Okay. And the shear stress is 22.1 Newton per mm square. Do you think these two stresses are acting individually on the spring? No, these two stresses are acting combinedly. Okay. So when the two stresses are acting combinedly, we have to calculate the combined stress also. That is very, very important. Okay. So because we have to know whether the spring can able to carry the stresses when the member is subjected to bending and shear combined together, whether it can able to carry it or not. So that we have to calculate. Okay. So based on the individual stresses, we are going to calculate the combined stress formula, which I am going to write now. Okay. So let's take a new one. Okay. From here, please continue the session. Okay. Right. So let's calculate what is the combined stress. Note down combined stress on open coiled helical spring okay. So which is, note down, this is very, very important. Sigma is equal to FB, nothing but bending, by 2 plus or minus root of FB square by 4, sorry, plus students are admitting continuously. Okay. Plus, not plus or minus, it is just plus. Okay. Plus Fs square. Okay. So this is very, very important. So this is the formula where you have to consider when a spring is subjected to both bending and shear. Okay. So let's substitute the values and see what will be the stresses. Sigma is equal to, what is FB? 9.41 by 2 plus or minus root of 9.41 okay. So you can write it like this. You can substitute all the values and see what will be the combined stresses, okay, which is acting on the open coiled helical spring. 1 second. Yeah. By 4 plus, what is the shear stress amount? 22.1 whole square. Okay. So tell me what is positive stress and what is negative stress. By solving this, you can get 4.705 plus or minus 22.595. Okay, so where one stress will be 27.3 Newton per mm square, and the other stress will be in the negative 17.9 Newton per mm square. Okay, so this is what the combined bending stress which is acting on the open coiled helical spring. Clear? Right? From this, we will see what will be the maximum intensity of the shear stress. The maximum intensity of shear stress, only the shear stress without considering any bending. What will the maximum intensity of the shear stress? Root of FB square by 4 plus FS square. So you substitute these values, you will get around 9.41 square by 4 plus 22.1 square. This is 22.6 Newton per mm square. So this is your maximum intensity of the shear stress which is acting alone. Okay, right? See, by considering all these values, which you have to consider as your maximum stress, is it sigma 1 or sigma 2 or the shear stress alone? Which one you have to consider, Amma, for designing your spring? You have to consider 27.3 Newton per mm square as the maximum stress, okay, which is acting on the spring for the design. Okay, so why? Because that is the combined stress which is acting on the spring as stress as 27.3 Newton per mm square. Clear? Okay, so with that we have calculated the stress. Now in this problem, this is what they asked you to calculate. What is the stresses acting on the spring when it is subjected to both bending and shear? Okay, now let's go to the second problem. In the same question, they ask you to calculate, replace the load with moment, okay, of 8 Newton into meter, and calculate what is the angle of rotation and what is the deflection. Okay, so let's do that. In the same question, what is the second bit? If the axial load is replaced by an axial torque, okay, then what will be the angle of rotation? Okay, so nothing but you are going to replace 300 kilonewton axial load with 8 kilonewton into meter of torque. Okay, then what will be the angle of rotation? Calculate pi here again with the change in load. 64 mr n secant alpha by d power 4. I think you all know these formulas which we have wrote for open coiled helical spring, plus sine square alpha by n. Okay, so this is the formula you have to remember when you want to calculate the angle of rotation based on the torque. Okay, substitute all the values. 64, what is moment? 8 into 10 cube, as it is 8 Newton, sorry, not kilo, Newton, sorry. 8 Newton into meter, kilometer kaadu, Newton into meter.
Axial load also 300 newtons, no sir? Axial load.
Not kilonewton kada?
Yes, a Newton, sir.
Sorry. Okay. Anyway, we are replacing the load, right? Okay. So now the load is replaced with moment. So here, instead of W, we are writing M. 64, 8 into 10 cube into, and what is the radius of the wire? 50. So radius of the coil is 50. Number of turns 12. Secant 12 degrees. And what is the diameter of the wire? 15 power 4 of 2 cos square 12 degrees by 2.1 into 10 power 5 plus sine square 12 degrees by 0.84 into 10 power 5. Okay, substitute all the values. You will get the angle of rotation as 0.0597 radians. Nothing but 0.059 radians into what is the angle, Amma? 3 degrees 21 minutes. How to convert radians into angle? How to convert radius into angle?
5 by 180.
80 by. And then right? And the deflection. Calculate the deflection which is given by. Okay, calculate the deflection. What is the deflection formula? (64 m/r squared n sin alpha by d power 4 of 1 by n minus 2 by e. Okay, so this is the deflection formula based on the moment. Okay, please note this and calculate what is the deflection based on the moment. Substitute all the values. 64 8 into 10 cube 50 square 12 sine 12 degrees by 15 power 4 of 1 by 0.84 into 10 power 5 minus 2 by 2.1 into 10 power 5. What is the deflection number? So you will get a value of 15 mm. Okay, you can calculate 15 mm. See, now we will try to compare the deflections which you got based on the axial load and the deflection based on the torque. I mean axial torque of 8 Newton into meter. So for which load your deflection is more? For the torque or for the axial load? For the torque or axial load? See, this is a deflection for torque. What is the deflection for an axial load, Amma? Deflection for an axial load. Enda? You can see it.
6.8.
6.86 mm. Okay. Now you tell me for which deflection you have to design your spring to take care of. Because due to more torque, your spring is having more deflection. So you have to design your open coiled helical spring to resist deflection of 15 mm. Why? Because that deflection is more compared with an axial load. Okay. So if you design your spring to resist a torque of 8 Newton into meter. Okay, will it be safe with a deflection of 6.86 with the load of 300 Newton? Safe untunda rada? Cheppandi. మీరు 8 Newton into meter కి మీ స్ప్రింగ్ ని డిజైన్ చేశారు అనుకోండి, will it be safe even with the deflection of 6.86 with the load of 300 Newton?
Yes, sir.
Yes. So that's the reason why so that is the reason why we have to design your member based on the failure, okay, or based on the failure pattern of the member, right? So that's why you have to design your member to resist the torque of 8 Newton into meter. Clear? Right. So this is the problem where you have to be practiced for open coiled helical springs. Right. Now we will move on to next problem, which is on leaf springs. Okay. Leaf springs can also be called as a bending springs. Okay. So we will move straight into that. Okay. So please note down this problem. Fast gamma. మీరు అన్ని ఏమైనా డౌట్స్ ఉంటే యూ కెన్ నోట్ ఇట్ డౌన్ అండ్ యూ కెన్ ఆస్క్ మీ లేటర్. ఓకే, సో లెట్ us finish the problems first. Okay, right, note down this problem. So this problem is on leaf spring. Fast note చేయండి. A leaf spring has 12 plates, each 50 mm wide and 5 mm thick. The longest plate being 60 mm long. The greatest bending stress is not exceed 180 Newton per mm square. And the central deflection is 15 mm. Estimate the magnitude of the greatest central load that can be applied to the spring and take E as 0.206 into 10 power 6 Newton per mm square. Okay, this is the problem given. So please note on that. See, you can come across these kind of problems in competitive exams. Okay, very small problems. Here you have to remember the formulas. That's it. If you remember the formula, solving these problems will become very easy. Okay. Right. So let's start doing this. So what they have given, Amma? Problem number 5. What they have given? So there is a leaf spring of how many plates? 12 plates. So leaf spring will be usual like this. Okay. Sorry. Yeah. Okay. So these are having different plates, Amma. So all these plates, there are around how many plates? There are around 12 numbers of plates. Okay, and each plate is having a dimension of, if you take the plate, so the plate dimension is 50 mm wide and 5 mm thick. Okay, so 50 mm wide and 5 mm thick. So this is the dimension of the plate, and the longest plate is being 600 mm long. So that means the length of this plate, the longest plate length is around 600 mm length. Okay, so the greatest bending stress is not to exceed 180 Newton per mm square. And the bending stress code already ichar, right? So bending stress is given as 180 Newton per mm square, which it should not exceed this. And deflection is also given as 15 mm. Okay, the central deflection is also given as 15 mm. Estimate the magnitude of the greatest central load that can be applied to the spring. For getting this deflection, what should be the maximum central load? Okay, what should be the maximum central load to have the bending stress of 180 Newton per mm square to get the deflection of 15 mm అని అడుగుతున్నారు, right? Understand? So they are asking you to calculate what is the load acting on the spring. Okay, load acting on the spring, which makes your beam should have a bending stress not to exceed 180 Newton per mm square and will have a deflection of 15 mm. Okay, so this is what they are asking you to calculate. And first one, let's see from deflection equation or from the deflection consideration. Okay, here you need to just remember the formulas. By that you can able to solve the problem easily. From deflection consideration, W is equal to 8 delta E N B T cube by 3 L cube. Okay, very important. If you remember this formula, you can able to calculate the load easily. Okay, right? So we have to do it in two ways. So this is the first way based on the deflection consideration. Okay, calculate what is W. Substitute all the values. 8 into what is the deflection given number? 15. What is E? 0.206 into 10 power 6. What is N? Number of plates? 12. What is width of the plate? 50. What is thickness of the plate? 5 by 3 into what is the longest length of the plate? 600 cube. Okay. What will be the load? 2860 Newton. Please solve it. You will get the load as this. Okay. And for getting deflection of 15 mm, your spring is subjected to load of 2860 kilonewton. Nothing but 2.86 kilonewton. 2860 Newton. So which is 2.86 kilonewton. Okay, where your leaf spring is subjected to a deflection. Okay, so this is based on the deflection consideration. In the same way, let's calculate what is the load based on the stress consideration. Okay, why? Because in your problem it is clearly given the bending stress as 180 Newton per mm square. So based on the bending stress consideration, let's calculate what is the load. Okay, from stress consideration, what is the stress formula? Bending stress is equal to 3 by 2 times of WL by NBT square. Please, you have to remember all these formulas for your GATE or for any competitive exam. Okay, FB is equal to 3 by 2 times of WL by NBT square. In this, you know the bending stress, you don't know the load. Okay, take your load out. W is equal to 2 FB into B T square by 3L. Okay, substitute 2 into what is the bending stress given? 180 into what is the, sorry, N is also there, right? NBT square kada? NBT square. Yeah. How many number of plates 12 into B 50 thickness 5 square by 3 times of 600. Okay, and the load is 3000 Newton, which is 3 kilonewton. Okay, now you tell me, based on the deflection consideration, your load is 2.86 Newton. Based on the bending stress consideration, your load is 3 kilonewton. Okay, so which is almost near, owner, right? So that is how you have to compare and see whether your leaf springs or carrier spring. So that the leaf spring can also be called as a carrier spring, leaf spring, or bending spring. Okay, so this is how you have to compare the two things. So this is GATE question number. So it was asked in the year 2017. So where as a blank. Okay, in the GATE lo meeku fill the blanks kuda untayi. Okay, so with these two formulas you have to calculate and compare the loads for deflection consideration and based on the stress consideration. Okay, so this is how you can solve what is that leaf spring problems, right? Leaf springs ni laminated springs ani kuda antaru. Okay, laminated springs ante because each plate was layered one by one. Okay, that's why it is called laminated springs ani kuda antaru. Okay, so this is how you can solve the fifth problem. Okay, right. So yeah, so let's note down the next one, sixth one. Yeah, note of this problem, because concept we can, okay, we can able to finish concept very easily, but solving problems and making them to understand relating with the real applications is very important. Okay, ఎందుకంటే కాంపిటేటివ్ ఎగ్జామ్స్ లో ఎక్కువ ఇలాంటి ప్రాబ్లమ్స్ అడుగుతుంటారు. ఓకే, థియరిటికల్ ఎనీవన్, you even if you study the theory also you can able to understand. Okay, so అందువల్ల problems we are concentrating much. Please note down this. There is another problem on leaf springs. With this we can close the problems on leaf springs. Note down this. A laminated steel spring simply supported at the ends and centrally loaded with a span of 75 centimeter, okay, is required to carry a proof load as 7.2 kilonewton, and the central deflection is not to exceed 50 mm. And the central deflection is not to exceed 50 mm. The bending stress must not be greater than 400 Newton per mm square. Plates are available in multiple of 1 mm for thickness and in multiples of 3 mm for width. Determine what they are. Determine suitable values of thicknesses, width and number of plates, and the radius which the plates should be formed, and assume the width to be 12 times the thickness. Width ఎంత ఉండాలంట? 12 times the thickness ఉండాలంట, and take E as 2 into 10 power 5 Newton per mm square. Okay, that's it. Note down this. Very important. See, you have to practice problems like this for preparation of external examinations. Okay. నోట్ చేశారా? Yeah. Okay, right. So let's do this. Very simple. Okay. What they given, Amma? A laminated steel spring simply supported at the ends and centrally loaded with a span of 75 centimeter. Okay, so that means, so let's straight away draw spring in a form of a member spring. Okay, leaf spring. So it will be in a bending form. Okay, laminated steel simply supported at the ends and centrally loaded with a span of 75 centimeter. Okay, and at a span of 75 centimeter, it is loading with 7.5 kilonewton. అంటే 7,500 mm. Okay, and the central deflection is not to exceed the, due to this load, the deflection of the beam, okay, of the laminated spring is given as not to exceed 50 mm. Okay, and the bending stress must not be greater than, bending stress is also given FB anachu, okay, or sigma B anachu, whatever it is, and the 400 Newton per mm square, right? plates are available in multiple of 1 mm for thickness and in multiple of 3 mm for width. Okay, so you can take thickness as 1 mm or multiples of 3 mm of the width కూడా తీసుకోవచ్చు. And they are asking you to calculate what is the suitable thickness, width and number of plates for getting the deflection of 50 mm or with the bending stress of 400 Newton per mm square. Okay, so this is what they are asking you to do. And the problem 6 and the given data we have already noted here. The load is given and the span is given, deflection is given, bending stress is given. Along with that, Young's modulus is given as 2 into 10 power 5 Newton per mm square. Okay, and straight away we will note down the deflection formula. Deflection is equal to 3W L cube by 8 E N B T cube. Okay, so this is the deflection formula of laminated springs. Okay, or it can also be written as NBT cube is equal to 3W L cube by 8 E delta. ఇలా కూడా రాయొచ్చు. Okay, so anything is possible, right? Okay na? Right. So from this this is the first formula, right? And the second formula which we need to calculate based on the bending. Why? Because there are two parameters given. One is the deflection parameter, other one is the bending stress parameter. So this formula is related to deflection, and the other formula which I am going to write now is based on the bending stress. Okay, based on the bending stress formula. What is that? B is equal to 3/2 of WL by NB T square. ఇదే కదా ఇందాక మనం ఆల్రెడీ నోట్ చేసాం. The same formulas which you are noting down again, or it can also be written as NBT square is equal to 3WL by 2F. ఇలా కూడా రాయొచ్చా? We can write even the deflection bending stress equation also in this form. Okay, ఎందుకు నేను ఈ ఫార్ములా రాస్తున్నాను చెప్పండి? Can anyone? Why I am writing the bending stress equation or bending stress formula in this form? Because if you are trying to observe these two formulas, deflection formula and bending stress formula, this is NBT cube and this is NBT square. Okay, from this what you can able to calculate? From this what you can able to calculate, Amma?
Width and thickness.
Yeah, you can able to calculate the thickness of the plate. Okay, that's why these formulas can be written in this form. Okay, right. So now what we do is, here we are going to dividing 1 and 2. Okay, so which you are going to get T is equal to, why? Because if you divide both equations, NBT cube, NBT square, there will be only T exists, right? So that's why T is equal to 3W L cube by 8 E delta of 2F by 3WL. Isn't it? Correct ena? చూడండి, రెండు ఈక్వేషన్స్ ని డివైడ్ చేయండి. 3WL cube by 8E delta into in denominator కాస్త న్యూమరేటర్ అవుతుంది 2F by 3WL. Okay, so finally this can be written as T is equal to, దీని ఎలా రాయొచ్చమ్మా? L will get cancelled, right? So finally this is L square into F by 3 will get cancelled. Okay, 2 times of 4 E delta. So this is your thickness formula, okay, where you can able to calculate the plate. Substitute all the values here. What is the span of the spring, Amma? 750 into, what is F? What is the bending stress given? FB 400 by 4 into, what is the Young's modulus given? 2 into 10 power